These are the examples that go with lesson 2.2, frequency distributions and their graphs. Example 1. How much air pollution is caused by motor vehicles? This question was addressed in a study by Dr. Janet Vanowitz at the Colorado School of Mines. She studied the emissions of particulate matter, a form of pollution consisting of tiny particles that has been associated with respiratory disease. The emissions of 65 vehicles in units of grams of particles per gallon of fuel are presented in the table. Construct a frequency distribution with class sizes of width 0.5. Alright, the first thing we want to do is figure out where the maximum and the minimum values are located so that we'll know exactly how many classes to put in here. Alright, so I have a value here of 0.25. So let's see. Looks like that might be the smallest one that I have. Alright, so this is the minimum value right here. Alright, now let's locate our maximum. There's a 3.12, 3.36, 3.47, 3.67, 3.79, 5.94, 6.55, 6.64. Here's an 8.06. Alright, so it looks like our maximum value is going to be right here at 8.06. Alright, now I'm going to go over to a new slide here, and we're going to create our frequency distribution table. Alright, we're going to have our classes, and we're going to have our frequency here. Actually, I'm going to change that. Oops. And we'll put those tallies in there, and then we'll put our frequency as the last one. Alright, so our class sizes are supposed to be 0.5. That means my first class is going to go from 0 to 0.49, and then the next one is going to start at 0.5, and it's going to go to 0.99, and we'll continue on down here. Okay, so here's my chart, and now I have all of my classes listed over here on this side, and I can make sure to include my minimum and my maximum. Remember, my minimum was 0.25 and my maximum was 8.06, and this one goes all the way to 8.49. Okay, so what I'm going to do now is I'm going to work in the middle column here, in the tally column, and I'm going to go back over to my chart here, and I'm going to start with this column right here, and I'm going to put each one of those into one of the columns in my frequency distribution table, and I'm just going to make a little tick mark, just a little line like this, and then when I have a next one, I'm going to put another one and another one and another one, and when I have 5, I'm going to cross through them. Now this is going to make it easier for me to count at the end when I try and figure out what the frequency actually is. Okay, our first number, 1.5, is going to fall right here between 1.5 and 1.99. And then our next number, 1.48, is going to fall right in here between 1 and 1.49. And then our next number, 1.40, is going to fall in the same category here, between 1 and 1.49. And then 3.12, that's going to be right here in between 3 and 3.49. And then 0.25, that's going to be up here in our first category, which is 0 to 0.49. Okay, now I'm just going to go back and do each one of the columns and put them into this tally column and figure out where all of my data points go. Okay, so once we have all of the data placed in one of our classes over here, then our frequency is just going to be the number of tally marks we have in each column. So we've got 2 in here, and there are 7 here, and there are 19 here, and 7 here, and 7 here, and 4 here, and 8 here, and 4 here, and 2 here, and 1 here. There's nobody in this column. 1 here. There's nobody in this column. 2 here. Nobody in this column. Nobody in this column. And then 1 in this column. And then one thing we want to be sure and do once we have the frequency distribution done, we want to go back and we want to add this. We want to get a total of all these items in the frequency column and make sure that that's equal to our original number of data points, which was 65. And I did check this in the calculator to make sure, and this column actually does equal 65. So let's put a note on here. Let's make sure the frequency is equal to the total of the data that we have. All right, and that's how we make a frequency distribution. Example 2. The table presents a frequency distribution of the number of live births to women ages 15 to 44 in the state of Wyoming in a recent year. Part A, list the lower class limits. All right, the lower class limits are going to be right here in this half of the age column. In this case, we're looking at 15, 20, 25, 30, 35, and 40. Part B, what is the class width? Well, we get the class width by subtracting 2 consecutive lower class limits. So if I subtract 20 minus 15, I'm going to get 5. And of course, 25 minus 20 is going to give me 5. And 30 minus 25 is going to give me 5. And 35 minus 30 is going to give me 5. And 40 minus 35 is going to give me 5. Our class width is 5. And you can pick any pair of these to subtract. I was just showing you that they all have to have the same class width. So they all had to be equal to 5. If they weren't, then there would be a problem with our frequency distribution table. So be sure when you make your classes that they all have the same class width. Okay, now part C is asking us to construct a frequency histogram. All right, and I'm going to do that on the blank slide next. But before we do, we need to pick out our lowest total, or our lowest frequency over here, and our maximum frequency so we can figure out how to scale the Y column, or the Y axis there. All right, so our minimum is going to be down here at 109. And our maximum over here looks like it's going to be this 2,410. Okay, so the first thing I notice is that we're going to have to go up at least to 2,500. Now, if I scale my y-axis by hundreds, that means I'm going to go up 25 places, and that's a lot to draw for a histogram there. So let's see if we can pare this down some. If I go up by 500s, that's going to put me at 5 on the y-axis. So I could do that, but let's show a little more detail. Let's split that in half and let's go up by 250s, okay? We're going to go up by increments of 250. All right, so over here, we're going to put in our frequency histogram. And right here, I'm going to scale my y-axis. And this is going to be 500. And this is going to be 1,000. And this is going to be 1,500. And this is going to be 2,000. And this one's going to be 2,500. And then in between, we've got our 250, 750, 1250, 1750, and 2250. And of course, we'll have 0 down here on the bottom. All right, over on the side here, the x-axis, I'm going to scale with the lower limits, okay? And our lower limits went from 15 up to 40. And I'm actually going to have to go out one more to 45 because my ages stopped here at 44. So when we scale our x-axis, we're going to have to go one lower limit beyond what we're given. All right, so we got 15 here, and 20, 25, 30, 35, 40, and remember I'm going to go one further. And that's so I can complete the rectangle for the class that goes from 40 to 44. Okay, from here to here represents the class from 15 to 19. So this is going to be an all rectangle all its own. From here to here represents the class that goes from 20 out to 24. And so that will be this rectangle going from 20 to 25, and so on. All right, and down here we should label this. So this is the age of the mother. And over here on the y-axis, we have live births. All right, let's draw our histogram. Let's see. For 15 to 19-year-olds, there were 795 of them. And that's going to fall somewhere in here between 750 and 1,000. So I'm going to go up in here, and then over. And then I am going to color this guy in. All right, and then for my 20 to 24s, we have 2,410. So that's going to be somewhere in here between 2,250 and 2,500. So we're going to extend this side up in between here and all the way over to the 25 and come down. And then we'll color this guy in. And then our 25 to 29s, we have 2,190. So that's going to be in here between 2,000 and 2,250. So I am going to put my bar right in here and then extend my rectangle down here to 30 and then color this bar in. And then from 30 to 34, we have 1,208. That's going to be here in between 1,000 and 1,250. So we're going to come in here and extend this one across and come down to 35 and color this one in. And then from 35 to 39, we've got 499, so that's almost 500. So I'm going to be just a hair underneath 500 right here. And we're going to go out here to 40. Color that one in. And then finally, the 40 to 44 people, there are 109 of those births. That's going to be down here under 250, so I'm going to make sure I have this bar underneath there and come out here to 45 and color that in. And there is our histogram for the age of the mother versus live births. All right. Part D here is asking for a relative frequency distribution. Okay, before we can make the relative frequency distribution, we need to know what the total frequency is. So we're going to have to add that frequency column together. And this is giving me 7,211 when I add these in my calculator. Okay, the relative frequency is just the frequency of each category divided by the total frequency. And so what I normally do is I will add in another column over here, the relative frequency. And then remember, we're just going to do 795 divided by 7,211. And I'm going to round this out to 3 decimal places. And this is going to give me 0.110. And then I'm actually going to do this for each of my categories here. All right, and so now I have added in my relative frequency column, and we have our relative frequency distribution. And I got these numbers again just by dividing each one of my frequencies by my total frequency. And then I rounded it to 3 decimal places. All right, part E, we're going to make another histogram. This time we're going to make it with our relative frequency column. So I'm going to keep the same x-axis that I had for my frequency distribution, but my relative frequency is going to be scaled a little bit differently because all of these numbers are less than 1. They're more than 0 and less than 1. So now we have to figure out how we're going to scale it. Okay, let's see. The minimum number in our relative frequency distribution is 0.015. And our maximum value in our relative frequency distribution is 0.334. Okay, so here's one way that I can scale this so that this is not a mystery about how I got the scales for the frequency distribution or for the relative frequency. If I add the maximum value to the minimum value, this is going to give me 0.349. Okay, now if I would like to have 10 items over here on my Y scale, then I can divide this by 10 and it should tell me what my incrementing should be. And this is giving me 0.0349. And what this tells me is that if I do my Y scale by 0.3, 10's not going to be enough because I have a little bit left over, but I can do 11, and that should take care of everything in my relative frequency column here. So I think that's what I'm going to do. I'm going to scale my histogram by 0.03, and instead of going up 10 lines, I'm going to have to go up 11. All right, let's go to our next slide. All right, we've got our relative frequency histogram here. And on the side over here, alright, so we said this was going to be 0.03, 0.06, 0.09, 0.12, 0.15, 0.18, 0.21, 0.24, 0.27, 0.30, 0.33, and I actually think we need to go up a little bit higher, 0.36, because it was 0.334. along the bottom, remember, we're going to have the same x-axis down here. And don't forget to go out one extra lower limit so that we can draw the rectangles. And once again, we have the age of the mother down here. And then on the side, we have a percent of live births, because that's what the relative frequency is. It's a percentage. Okay, now let's go back to our relative frequency distribution and get our numbers. From 15 to 19, we had 0.110, and 0.110 is going to fall right in here between 0.9 and 0.12. So I'm going to draw this bar right up in here and come over to the 20 and drop it. And then we'll color that one in. And remember, this bar represents the class from 15 to 19. 20-year-olds are not included in this bar. They'll be included in the next one. All right, for our 20 to 24-year-olds, we have 0.334. That's going to take us up here above the 0.33, just barely. And we'll extend it across here to the 25 and bring it down. And then we'll color this bar in. The 25 to 29-year-olds, this is 0.304. That's going to fall in here between 0.30 and 0.33. So we're going to extend this one across and then drop it down to 30. And color this bar in. And coloring them in is not necessary. It just kind of makes the histogram easier to read. And if you can do them in different colors, that makes it even easier to read. 30 to 34, we've got 0.168. 0.16 is going to fall here between 0.15 and 1.8. So we're going to bring this one across, drop it down to the 35s, and color this bar in. And then 35 to 39, that's our 0.069. And so that's going to be just barely above the 0.06. Come across and drop it down. And then our last category there, which was the 40 to 44-year-olds, this is 0.015. These guys are going to be under the 0.03s. So I'm going to make sure that this bar is less than that. And come across and drop it and color it in. And there is our relative frequency histogram. They should look, excuse me, fairly similar to one another. And they kind of do. I think the relative frequency, looks a little more dramatic, but it's because of the way that we've scaled our y-axis here. Now, when you do these in the lab, you're going to do them in Excel. And the nice thing about Excel is Excel will scale your y-axis for you, and you can tell it what you want to use for the x-axis, because that will come in your class labels. And there's a video showing you how to do these in Excel. It's included in one of the folders in the weekly assignments. I think it's under the Excel videos content folder. Example 3. Classify each of the following histograms as skewed to the right, skewed to the left, or approximately symmetric. Let's look at part A. If we imagine the midpoints here in each of these rectangles, and then we wanted to draw a curve that connected those midpoints, it would look something like this. And when you can see the graph, I think it kind of makes it a little bit more clear. This one's going to be skewed to the left because the tail is over here on the left-hand side of our mode. So this one we're looking at skewed left. For part B, and again, we imagine these midpoints in all of these rectangles, or in the top of all these rectangles, and then we want to draw a curve connecting them. We're going to get something that kind of looks like this right here. Now, this is what we're going for. We want the mode to be right here in the middle, and we want everything to kind of taper off on both sides here. So this one is approximately symmetric. And then for C, and again, I'm just going to imagine these midpoints in here on the tops of the rectangles. And if we sketch our curve in, we're going to have something that looks like this right here. And again, the middle, our mode, is not in the middle of our curve here. The tail is actually over here on this side. And so this problem is going to be, or this graph is going to be skewed to the right. Example 4, classify each of the following histograms as unimodal or bimodal. Okay, for part A, the mode is located right here, and there is nothing else that comes anywhere close to having that many in the frequency. So this one is going to be unimodal. When we look at part B, it looks like the mode column is going to be located right here, this purple one, and the blue one's close to it, but they're not quite the same height there. So again, we're looking at unimodal here. And then for part C, I have a mode here, but then I look and I have another mode over here. And so this one's going to be considered to be bimodal because I have two peaks in my histogram.